welcome to the Homework Hotline studio, science studio, I mean. So I was just cutting a piece of paper that I'm going to need in just a second here. But we're going to be looking at density today. If you watched the show, you may remember that recently we did an experiment looking at plate tectonics and the way that continental plates or tectonic plates run into each other and how they might subduct. Do you remember this?
Yes.
Right.
It was with peanut butter and graham crackers.
Peanut butter and graham crackers.
Oh, it was good.
I'm not sure the date of the episode. It was a month or so ago.
It was delicious.
It was.
It was a
delicious.
delicious
It was a really
experiment.
great experiment.
This one's going to be a little less tasty, but hopefully just as interesting. So one of the things that was brought up in there was this idea that sometimes what you have is when you have two plates hitting each other, sometimes what you have is one that will sink below the other. And the rule that I gave you guys, I don't know if you remember, but I talked about continental crust and oceanic crust. Do you remember which one subducts below the other one always?
Oceanic crust is denser, right?
Yes, oceanic crust is denser.
And so it goes below.
And so it goes below it, what we call subducts, it goes below. So like if this is oceanic crust and this is continental crust, and they hit each other, the oceanic crust should sink below. And Becca just gave it away, it's density that is the difference there. So what is, no, you're told, no, I don't mean, not in a negative way, in a good way. What is density?
It's kind of like how much stuff you can pack into a certain size, right? So like if I don't know, I think about like rocks, like based on the size and how much it weighs, you're kind of packing more into that space.
More material into the space. It's like it's like the number, it's like the amount of mass in a given volume.
I always think of like when I pick up a package at home, I get home and then, okay, there's a package at the door and it's really big, you know, and you pick it up and it's really light actually because it's filled with styrofoam or
the stuff inside is
a very small one that you pick up and you're like, whoa, really dense.
Definitely. Or like a prop for a movie, right? That like looks like a brick and you chuck it at somebody and it hits them in the head, but it's made of foam.
You know, actually I have a foam brick and an actual brick that I use sometimes with my students to talk about this very idea. Nice. Or even if you saw earlier when I was showing the diagrams related to boiling point, if you noticed, the air is denser down at sea level. It's tighter, it's more packed together, the air molecules are, and it's less dense up at altitude. So we're going to be looking at this idea of density with water and sort of thinking about this idea of you know, can we see examples of more dense things sinking, right? If oceanic crust subducts below continental crust, where's some evidence for that? So we'll look at 3 densities of water. So I've got here ice water, room temperature water, and then hot water. It's not quite boiling. I just checked the temperature. It's about 170 degrees. So still really hot. And actually, we're going to have to be just a little careful because of that. Okay, and then I also have in my handy dandy pocket here some food coloring items. I was maybe missing one, but that's okay. All right. So what we'll start with is room temperature water. So what we want to do is just kind of see what happens when we mix when we mix things that are the same density. And we could imagine thinking about rocks. No, that's fine, Becca, I appreciate it. So we could imagine on the Earth 2 continental crusts hitting each other and not really subducting above or below each other, or 2 pieces of oceanic crust hitting each other and maybe being the same density. So we'll do that with room temperature water, okay? So Becca, would you do me a favor and fill, and we'll do this actually in the Pyrex pan. Will you fill that guy up to the brim with room temperature water?
Sure.
All the way up there. And in fact, fill it up so much, Becca, that it pours over just a little bit.
So we're going to move some of this.
Oh yeah, definitely, please.
So that it pours over?
Let's get a clear shot there.
There we go.
Is that what you're looking for?
Yep, that's perfect. And so what Becca's done there is just filled it up completely. We want to make sure there's no air pockets here. Nate, if you could do me a favor and fill this guy also in the Pyrex with that same water.
Same water? All right.
Okay, perfect. And then what we'll do is let's add green food coloring to just one of these. Maybe you can go ahead and add it to yours, just a drop or 2.
I always like watching the food coloring.
Yeah,
it looks really cool.
It's beautiful.
Yeah.
And I'm actually just gonna speed us up a little bit. We'll have an opportunity to sort of see this happen in slow motion for a couple of these. But all right, we've got some green water and some clear water. Nate, can you just top that guy off for us?
I would top it off with water?
Yep. So what we're going to do here is something that you can do at home, as long as you have 2 vessels that have the same size mouth opening. I'd recommend doing this with glass jars or glass cups, but it works pretty well with these beakers, so we're going to try it with that. Okay, so what you need is beakers or glasses filled completely up with water like this. And then what I have here is just a little piece of cardboard or cardstock, right? Anything semi-stiff like this that I can put over the top is gonna work. What we're gonna try to do, Nate, and I'm gonna have Nate do this first one. Are you ready?
All right.
I'm gonna have you flip the green one upside down.
Oh, easy.
And place it gently on top of the clear one there, okay? And we'll keep it
right.
inside the Pyrex pan just in case there is any spillage, Nate,
magician.
you know, life goes on. So what you wanna do is, and I won't do it, but I'll just sort of show you, what we're gonna do is we're actually gonna push this down, we're gonna push this down right on top of the green beaker here, sort of pushing some of the water out of the way. Then you'll hold that down as you flip it up, put it together, and then slide the cardboard.
Gotcha.
Does that make sense?
Yeah.
All right, Nate, I believe in you. I know.
Pressure.
I know.
Okay.
The stakes are high. Beautiful.
Oh.
Okay, great. No, fantastic. And you want me to help with the cardboard?
Yeah.
Okay. All right, and that should just sit right there. And hopefully you can see at home. What do we have? What do we have going on here?
Not too much color transfer, a little bit.
Just, yeah.
Yeah, would you describe that as like a slow color transfer?
Definitely slow.
So when we have
Now-
go ahead.
Oh, sorry. Is that because I possibly lost some water?
No,
Okay.
actually we would expect it to be
Possibly,
slow
okay.
in general because when we have two things mixed that are the same density, the mixing and distribution of them is going to be not really dramatic, right? When we have
Right.
things that are of high density and low density that get mixed together, that's when we tend to see more significant results. Now, just as before we move on to hot water and cold water, which is more dense, hot water or cold water? And why? Do you guys know?
I feel like it has something to do with how fast the molecules move. I don't be totally wrong on that.
Cold water,
Is-
yeah,
is
because
what?
is more dense.
Yep.
Because the molecules are not moving as fast.
Yeah,
Okay.
and it allows them to pack more tightly
Yeah.
together in the same amount of space.
And whenever it's hot, they're kind of moving all over the place and bouncing all over each other and
They kind
expanding.
of just spread out.
Yeah.
Exactly.
Right.
So I wanted to try two of these. I was thinking of what we do. I've got a number of other beakers here. I wanted to try one where we'll put the cold water on the bottom and the hot water on top, and then we'll do one where we flip it and put the hot water on the bottom and the cold water on top.
Okay.
Okay?
All right.
So let's actually take this guy. We may be able to safely transfer him over to the side here. Oh gosh.
Good luck.
Or not safely if I'm not careful. Dun 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 dun.
What could go wrong?
What could go wrong? And we'll see how that. We'll see if that transfers any more as we go through here in this experiment. All right. So let's do hot on the bottom and cold on the top, right? So we should see the most dramatic effect there. So cold on the top being more dense, what we should have is the cold should sink and the hot should rise. Okay.
Okay.
So what we'll have, and Derek, you want to do this one for me?
Sure.
Take some cold ice water there. Let's have you use this one. Fill that completely up for me. And I'm sorry, let's put it in the
do it in there?
Pyrex
Yeah.
pan so you can actually let it spill over a little.
Is that ice going to affect it?
You know, my cause this later shouldn't be a big deal.
No, but it's right on top.
Okay.
Do you want to get it out?
Can you get it out, man?
I think
You can? I got fat fingers.
Nope. We'd have to pour it out.
Becca's got tiny fingers. Come on.
We could pour it out really quick.
I believe in you. Or you can try to pour it
Oh.
directly into the...
I almost got it. This is like a game.
This is a fun
This is such
game.
a good game. Okay, let's try that. Try again. Here.
Try again.
It's good teamwork.
Icy will not.
Okay, so we
make
got
it
that cold
through.
water. Nate, go ahead and fill this guy up for me with hot water.
Hot water.
And Becca, in the meantime, why don't you put some yellow in our cold water for me?
Okay.
Oh yeah, that is pretty hot.
Yeah, it is indeed. Okay,
There you go.
all right, and
I'm
then
gonna put this back here so it's not in the way.
Nate, would you put some green food coloring in the hot water? I had intended to bring blue and yellow food coloring, and I thought I did, but I must have been a little colorblind when I was going through my cabinet before this. So what would have been nice about the blue and the yellow is they would have mixed to green, but we're just gonna have to deal with green and yellow mixing. All right, Nick, can you top that up just a little bit more?
Yeah.
Okay, now we actually want to put the cold on top of the hot. And the reason being, I think we'll see the most intense exchange of colors here, because what will happen is the denser cold water is going to want to sink, and that warmer, less dense water is going to want to rise. So, Becca, I'm going to have you do this one if you feel prepared. So it's the cold one. Don't touch that hot beaker, okay? So it's the cold one. Go ahead and push that on top. and just hold it there and flip it gently.
Oh, God.
I know. You got this. I believe in you.
Oh, God.
Do you want me to try to pull it out when you're ready?
Yeah.
So let's line it up a little.
And yeah, just make sure you line it up there.
You got it?
I think so.
Ready?
I believe in you. I believe in both of you. Beautiful.
Oh yeah, the green is definitely
And again,
coming up really
unfortunately not the best exchange because of the colors that we have.
Cool, but I don't know if it's going to stay.
It should. Hopefully. Well, I don't know how to. And,
Yeah.
Balancing it.
And look at that. Within like a few seconds.
Yeah, wow.
Yeah, you can definitely tell, like,
And you
whereas
can
here it's
see-
still clear.
You can see the movement in the water, too.
Yeah,
Yeah, you can see
kind of
that.
the swirling, right?
Yeah, it is. Maybe
Yeah.
it is. And I think folks at home, you can probably see those bubbles rising there. And
Temperature.
well, still cold on top and warm on the bottom. But this sort of what this demonstrates is this idea of density, right? And how one thing will sink through another, right? So again, if we had a dense piece of oceanic crust hitting a not so dense piece of continental crust, it's going to be sinking through it. Even though we're talking about rocks here in this case, when we talk about the mantle of the Earth, we're talking about an area where rock is heated so much that it actually flows like a fluid. That's one of the things that allows this to happen. The last one I was gonna try was to see if we could just do it the opposite way here. Oh my gosh. Dun, 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 dun. Okay, so we'll try to do this quickly. What would happen if we put cold on the bottom?
I feel like if the hot air wants or the hot water wants to rise and the cold
Yep.
water wants to stay on the bottom, then it should actually not do anything.
Yeah, it should keep them totally unmixed. And we can see even our control over there with just room temperature water.
It's mixing a little bit. There
Oh
goes
my
that.
goodness. Well, that was
Woo!
exciting.
Missed me entirely.
Did that miss you entirely?
Yeah, it just
Oh,
got you, I
good.
think.
What got
Yeah.
just my
Like
hand?
our elephant toothpaste.
Actually,
thing.
wasn't.
All
It's
Becca.
not even close. Oh my God, elephant toothpaste. Go back and watch the video of Becca
Oh
doing elephant
my
toothpaste with
That
us.
was our best
Gosh.
science experiment.
It was pretty fantastic.
That was really fun.
Okay, so I'm gonna try to do this. I'm gonna do this quickly to try to get the thing on top. All right, so let's see if we can. Let's just do. Nate, can we just dye this one guy green?
Yep.
Again. All right, and this is the hot water that Nate just dyed green. So I'm gonna put the hot water over the cold water, and we'll see if we can notice any exchange. Again, even our control here, there was very little diffusion of the green, but
There was some.
But there was some. All right, people, you ready?
Mm-hmm.
Oh God.
Don't burn yourself.
That's a little bit too hot.
Do you have a... Yeah, there we go.
Okay. Here we go. Oh, geez. Okay. Okay, and I'm actually having a little bit of a hard time with stability here. That's not too bad.
There it goes.
Okay, well, hopefully you saw before I totally destroyed it that the green was really staying above the clear water there. That was a little bit messy. Again, this is a little bit easier with glasses that have the exact same size rim, but I thought the visual effect of these was kind of cool.
And bigger rims too, right? Like, it's really actually hard to line up small rims.
It is kind of tricky to line up small rims. So anyways, hopefully you got the main idea there. We're going to take a break, clean up all this water, and we will see you back in just a few minutes in the Homework Hotline studio.